Namaskar, welcome to the channel Anka Anandaharan. In this video, we will do some of the problems of chapter 2. Already first three bits are being done. Due to some unavoidable situation, I had to reduce the video there itself. Now I will complete the rest part of the problem. Now let us discuss about D. What it is telling? My V is set of all linear combinations of all linear combinations of the vectors 1, 1, 0 and 2, 0, 1. It is given, which I can write it as span of E1, E2, where E1 is 1, 1, 0, E2 is 2, 0, 1. Now here clearly the E1 and E2 are not linear combinations of each other. That means they are linearly independent. So I have two linearly independent vectors. Now I am finding span of it. It is always a vector space. Span of any set of vectors will be always a vector space. So now let us prove it. Let U belongs to V. That implies there exists C1, C2 such that U is equal to C1 E1 plus C2 E2. Let W belongs to V. This implies there exists D1, D2 such that W is equal to D1 E1 plus D2 E2. These are arbitrary vectors. Now, as they are arbitrary vectors, so whatever their addition, now U plus W. What it is? C1 plus D1 into E1 plus C2 plus D2 into E2. That means it is again a linear combination of E1 and E2. That's why if any vector which can be represented as a linear combination of E1 and E2, that vector belongs to my V. So here this vector belongs to V. So as arbitrarily selected two vectors, their addition is in V. So I can tell that V is closed under vector addition. It is closed under vector addition. Now what about C into U? This is equal to C times C1 E1 plus C times C2 E2. So again it is a scalar. So again this is Cu is also a linear combination of E1 and E2. Hence that also belongs to V. So which implies our consider V is closed under scalar multiplication. So this is another property. What is the third property I should prove, which already it should be the first property, but now I missed the sequence. Zero vector is an element. So as zero vector it can be written as is equal to 0 into E1 plus 0 into E2. Hence, it is a linear combination of E1 and E2. So, this also belongs to V. So, V is, that implies V is not empty. It is property 3. So, from 1 to 3, what we got? V is non-empty, V is closed under vector addition, and V is closed under scalar multiplication. So, from 1 to 3, what we got? V is a vector subspace. V is a subspace of RQ. Okay, so this is our question D. Now what is question E? Question E is this. Just I will change the color to make feel that there are two different problems. B3 minus B2 plus 3B1 is equal to 0. Whenever linear combination of components of a vector is equated to 0, always it will give us a vector space. Okay, now we'll do the problem here. So what is our V? V is equal to B1, B2, B3 such that B2, B3 such belongs to RQ such that, listen, forgot. B3 minus B2 plus 3B1 is equal to 0. B3 minus 2B2 plus B1 is equal to 0. Set of all vectors satisfying these conditions are said to be is my V. All the vectors satisfying these conditions are in my V. So clearly first is 0 vector. So here belongs to V because put here 0, here 0, here 0, the resultant is 0. So that's why this implies V is non-empty. First condition is over. Next is let U1, U2, U3 belongs to V. This implies, what's the relation between U1, U2, U3? U3 minus 2U2 plus U1 is equal to 0. Similarly, let W1, W2, W3 belongs to V. That implies W3 minus 2W2 plus W1 is equal to 0. Let its name is U, let its name is W. What about U plus W? It is U1 plus W1, U2 plus W2, U3 plus W3. Okay, now whether this vector is belonging to V or not, let us see. So third component, that is U3 plus W3 minus 2 into second component U2 plus W2 plus first component is equal to how much? I'll write all the U's together, all the W's together. 2U2 plus U1 plus W3 minus 2W2 plus W1 is equal to, its value is 0, its value is 0 is equal to 0. So again, this U plus W also satisfied the same condition. So it will, so this, which implies U plus W belongs to V. That's why V is closed under vector addition. In the exam, you are expected to write it in full form. Already this term we are using so many times to save time and energy. I am writing in short form, but these short forms are not officially allowed. Next, C into U. How much it is? C U1, comma C U2, comma C U3. So here what is the relation? C U3 minus 2 CU2 plus CU1 is equal to, what's the value? 3 times U3 minus 2U2 plus U1. But this value is 0. So C into 0 is 0. So again this condition satisfied. This given condition is satisfied by Cu. That implies Cu belongs to V. As U is an arbitrary vector of V and C is any arbitrary constant, so V is closed under, therefore it is 0.2 and it is V is closed under scalar multiplication. So finally all the three properties are satisfied. So what is our conclusion? This implies V is a subspace of R cube. So I hope this problem is, so with this all of you have understood how to verify whether a set of vectors is a vector space or not. Thank you for your patient listening.